We are now in the module of the topography, and we need to acquire topography. But sometimes you can get some issues and trouble, and I'm going to show you how to avoid this kind of problems. So I'm asking to the patient to put the chin on the chin rest. Now you have to control that this line on the bar correspond to the height of the eyes. So now I'm selecting the patient's ear. I've already created the file, and I'm creating a folder in which the examination will be stored. I have to select corneal topography, and now I can see the image of the eye out of focus, and I can put the cross on the vertex of the cornea. Here you can see two slides of lights, and you have to put a slice of light directly in the center of the circle in this way. Here we have some problems. The main important one is in this area. You can see here that the circle reflection is not perfect, so we have like a cutting in the proper way in which the outer rings are reflecting. So I have to improve this reflection, and I can do very easily in this way. Can you remove please the chin? And then I can turn the chin rest in this way and ask the patient to reput the chin following the direction of the chin rest, the new direction. Once again, you have to look straight on the light, perfect. And now you can see that I've improved the reflection. But if I want to do more, please, can you remove the chin? I can turn again in this way, if it's not enough, and you can put the chin following the direction of the chin rest, okay? And now I have a much more improvements in the reflection here. So I'm ready to acquire, even though there is another problem. Here there is something on the reflection, so there is some artifact due to some not good tear film in this position. In fact, indeed, when she blinks, she removes the reflection, not quality in the reflection. So now let's acquire a couple of topography. So look the light, perfect. Can you open your eyes? Okay, good, good, good. Now I can get the first image. Again, can you look the light? Again. Okay, good. Fantastic. In this way, I can have an immediate and an overview of a preview of the most important information from the topography, and I can move back if you want to acquire more. So after the topography acquisition, we can analyze the data. So I can process the acquisition, and let's start from the toolbar up here above. I can edit the original acquisition. Let's assume you are not happy about the rings automatically highlighted from the system. You can remove part of the ring or add part of the ring and reprocess it. Then I can check, for example, for the pupil, and I can move here the size of the pupil if I'm not happy about the automatic analysis, or I can edit also the Y-to-Y diameter, changing here the position of the of this arc here or on the nasal and temporal side. Once we have done this, we had at a glance four different kind of topography maps, or I can pick just one. So what's the difference between this kind of algorithms that analyzing the topographical information? For example, axial curve is quite good in the center part, is a little bit smoother than the other. For example, the second one, it gives very good information about astigmatism. but it's not very good in terms of details of specific point that can be instead analyzed much better with a tangential curvature map, so I can get information more specific, more detailed in a certain point. With elevation map, I have information about the difference between the corneal surface analyzed and a reference surface, for example, a circle. In the refractive power, instead, I have integrated the refraction in a specific point, that it depends on the refractive index and the incidence angle of the light in this specific point. So what about the settings? You can change the setting of the processing. For example, you can pick different coordinates systems, so Cartesian or polar. Also, the curvature measure is quite important. It's pretty important. You can swap between diopters and millimeters. That is maybe much more informative if you want to fit contact lenses. Cylinder notation, negative or positive. Asphericity, we have different indices, so PE, shape factor, Q, and so on. Also, if you want to adjusting the so tailoring the ICL, you have to adjust to enable the adjusting wide to wide diameter. Also, the best fit type, you can select between spherical, aspherical, and so on, just for the elevation map calculation. And finally, you can include or not in the printing the keratoconus screening, depending on you want to give on the printing on the outputs. So that's it in terms of setting. So what about the scale, the color? So that these maps are color-coded maps, and so you can change the scale. For example, I can change the range here. I can, for example, keep the center point in millimeters 7.8, but I can change the steps. So this is 0.10 steps or 0.20 steps, and so on. Then I can normalize the scale, or I can also adjust the scale. So I can choose the central point, and I can adjust the delta as wish as I desire. And this is very important if I want to, for example, try to look to pick some very small, tiny change in fluctuations in the surface, for example. Once we have normalized the map, here it's possible to see a prototypic with the rule astigmatism, and I can overload to the map something. For example, with the right bottom of the mouse, I can choose to enhance the pupil size or the wide to wide diameter, so the wide to wide limbus, or for example the ruler. That is quite important if you want to get information about the size of these parts or some parts of the corneal shape. And finally, also is quite important the 3D map. That is very easy and friendly map to show also the patient here. For example, you can see with the rule astigmatism on the vertical, so with a steeper curvature on the vertical meridian. So what about information of the topography? We can get information from maps, but also from mathematical indices that represent an overall indices for the corneal analysis. So on this side, we have a toolbar. You can select, for example, the summary indices. Here, the summary indices are stands for keratometric maximum power, and also the wide to wide diameter or the pupil diameter and the offset of pupil compared to the vertex of the cornea. You can remove it or leave it. It depends on what you want to get from the view at a glance. Now I'm removing it. I'm moving on the second one. So the second one is the key readings panel. It gives you information about the the SIMK readings, but also you can select the 3 millimeters readings or the hemimeridians readings of the cornea. The third one is a table in which you can find information about the curvature depending on the eccentricity and also the asphericity of the cornea. Refractive analysis. In this case, you have some information, some very useful information. Just remove it. Sorry, I can leave it just the refractive analysis. So the first one is the longitudinal spherical aberration, and so it expressed in this case in diopters. But also you can have a longitudinal spherical, longitudinal chromatic aberration, and you can get information in terms of power, or as for example Zernike information. In this case is the root mean square of aberration. Also, this is possible for high order aberration, and once again you can select the information in terms of Zernike polynomials, and so you have the microns of the root mean square. So the shape indices represent the level of asphericity for a certain degree of eccentricity or diameter. So I can select a diameter, I can get information of the flatter and steeper meridian for that diameters and the asphericity. And finally, we can have information about keratoconus. So the first one is symmetry index. So the symmetry index is an index that can give you information about the difference between the power in the upper part of the cornea and the lower part. The BCV is an index of elevation, so give information about elevation of this shape. And also the final one give you information about the irregularity of keratoconus. These indices are sometimes quite difficult to understand in terms of equation that express the indices, so you can get information here from the question mark, and so you can recall if the right information how to understand the rationale behind this index. You can get information about the aberration of the eye clicking on this bottom here. And in this case, you have the wavefront error of the pupil entrance of 3 millimeters, where you can change the millimeters of the pupil entrance, and you can reanalyze, reprocess the information in terms of different aberration. Or you can look here at the Zernike pyramid, and where you can find the different polynomials and having the coefficient for each one. So you can analyze the data in terms of low order aberrations or high order aberration. Here you have a cylindrical power derived from the aberrations of astigmatism. Also, if you click on the right button and you get normative data, you have a very simple traffic light image that can allow you to get if you are inside the on the average, or the yellow bar represent, and the yellow and the red bar represent the 95% confidence interval of 95% and 99% respectively. So for each single aberration you have different information about the normative value. The software offers also the possibility to compare different data, different images. For example, here I'm comparing cornea before ortho-K treatments. So I'm selecting the first one, and I'm selecting a second map after roughly an hours of use of an ortho-K contact lenses. So here you have the baseline condition with tangential curvature or refractive power, and as you can see, after 42 minutes you can see the shape of the classical shape of ortho-K treatment for myopia, and the change also the power in the center pupil entrance, so with a reducing of power in this area. You can also subtract information between the two maps. So I can select here the baseline, as I previously did, and putting a second map, the map after the treatment, the 42 minutes of treatment. Here above I have the two maps with tangential curvature, so in baseline and after 42 minutes, but I want to get because I'm subtracting, and it's much more informative, a refractive power maps. And here you can see there is a change of the power in the pupil entrance, and I can get exactly the information in X, Y axis coordinates. And for example, here I have roughly 3/4 of diopters of myopia decreasing. So the treatment is working. If a pupillography has been acquired, you can select the pupillography immediately for the specific patients and see what happened in terms of pupillography compared to what you have just seen in terms of topography and aberration and so on. Very interesting is the contact lens fitting simulator. So I can simulate a specific, for example, contact lenses pattern, picking one lens from the what is available in the database from a certain manufacturer, and I can change according the specific steps of this lens. For example, the base curve or the diameter. For example, I have here been selected as 7.6 millimeters base curve rigid contact lenses of 9.8 diameters, and I have a profile of the thickness of the posterior, so the posterior film. And here, for example, you have roughly a certain amount of thickness and you can explore for each single meridian the thickness of the posterior tear film. If I change, for example, the base curve, and I pick a flatter base curve, you can see the fluoroscopic patterns of typically flat rigid contact lenses. Finally, we can print what we have just seen, or for example the maps, and I can choose to print in this way the maps with the indices, and I can print both in hard copy or in PDF file. So it's quite easy to export the output that you wish in a format available for the patient or for another colleague. What we have just seen is a print screen capture, but of course you can print a preset format of what you wish in terms of information that you want to give to the patient or another colleague.